Hello everyone. Here's another video around the AI architecture series, and this one I'm going to do a quick walkthrough on tool usage. Now, LLMs have been able to use tools for a while in the custom chat GPTs, and there's a variety of other major platforms that allow for tool usage like web searches and things like that. You also have platforms, agentic style platforms like N8N, where there's lots of integrations. Google Agent Space has lots of integrations, and pretty much everything is following suit right now. And not a lot of people know exactly how to make use of tools and how to build their own, because this seems to be the next wave of commoditization around AIs. And so I thought I'd take a couple of minutes and just show you a simple architecture that will help you understand how to chain together some of these different agents and to be able to use tools in your own code. And this means that you'll be able to spin up a solution in no time, publish an inventory of tools that your AI can check and reference, and then call those tools to connect to the world, do a Google search, do a database call, etc. And so here's a simple architecture. Have a look at it. Here you have a solution user and really any user interface with inputs and outputs for the human and AI interaction. So it could be a chat, but it could be anything else as well. That you shouldn't limit yourself to just the chat modality. It really could be a number of different things. So in essence, the user will create a prompt. And it really doesn't matter what it is. It could be what's the weather like, or what time is it, or how many widgets have I sold yesterday. And the first agent it hits has to be the prompt evaluator. And so this is pretty much a binary question. Would the response be better using a tool? Does the prompt name a specific tool? So if I say, what time is it? I may not be naming the tool that I want it to use. There could be a tool called check the time that it could look at in the inventory. So, or I could say use the check the time tool. But either way, it has to sort of make an inference because people are unpredictable. So let's say that it's evaluated that yes, a tool is useful. It will parse that response and it will take JSON out of that. So this first agent will create a JSON structured response, and it will simply say tool, true or false. And if it's false, it'll go up and attempt to answer the question without using any tool at all, so it doesn't waste any time doing a asynchronous call to using a tool. But if it's true, it will come and it will pull from a tool inventory. Now this is a service. It could be just a flat data file, or it could be an API that gets called if tool is true. And this API will return both a list of all of the available tools and the schema and methods to call them. So for example, if there is a time check tool, it should say that this is the way you call the tool. This is its identifier, some unique ID. And here's the inputs. For example, time zone maybe is a required input, or the time of day currently. Is it the time of day tomorrow at noon, what time that would be in Los Angeles? There's a whole bunch of different ways that could be interpreted. But the tool inventory API takes away any mystery of that. It's abundantly clear how it's being interpreted, and this is what you need to pass in. So that gets returned, and the next agent picks it up, and the next agent is tool caller. And so we haven't called the tool yet. We've simply just checked to see whether we have a meaningful tool. So the second agent is going to say, which is the correct tool for this job, if any? Do we have enough information to make the call now that we have the schema? And in fact, there could be multiple tools selected. And so it can come back with a list of different tools, and it can be parsed again. And let's say it comes back with 3 different tools. Maybe we ask the time and the temperature in Paris. Okay. So maybe it's gone off and called a bunch of different tools to get a weather API and a time API and a maps API so that it can pull all that information together. And it comes back and it executes those either sequentially or parallel. And it now actually calls the tools. So each of those tools is going to have an API endpoint that's going to receive a schema. So, longitude, latitude, date, time, country code, whatever is needed to trigger that. And it's going to attempt to return those results here to the results evaluator. And so the results evaluator will look at this, it'll look at the original prompt, and then it will look at the results of the tools and say, do these results provide a reasonable basis for answering the request? If not, is there another tool to consider? So if it's not the right results, or maybe the evaluator doesn't think we have what we need, it can trigger step 2 again and do another tool call with a different tool. Or it can say, yes, acceptable, true, and then it would return the results, which could be an LLM response. And then that result comes all the way back one way or another to the LLM response, and it gets put back into the user interface. And that's essentially it. And if you have more complex interactions, these methods, you could have a swarm of different agents, an inventory of different agents, all leveraging a common horizontally available, so commonly available tool inventory and tool API. So you could have, you could do that. The same architecture, interestingly enough, is useful in 2 other scenarios. One would be model selection. So right now, most of us are using a single model provider, LLM provider, but you could have a prompt evaluator that would do a similar thing and say, which is the best known LLM to answer this? And if it's a simple task, you could use a very lightweight model or a very fast model. So for example, you could use Grok, G-R-O-Q, and it could return you a result immediately. Or if it's the kind of question that requires more in-depth thinking, you could run a chain of thought model or one of those more in-depth models that could take anywhere from 30 to 60 seconds to run, like O3 or any of the other big thinking models, if you will. And it can run in a similar fashion. It could deploy your question to multiple different models concurrently and then figure out who has the best answer, which I really like that architecture. It's more costly in tokens, but it will diversify the type of results you get back. And it's also useful if you think of it as an agent orchestrator. So you could have the same architecture that you see here tying into receiving a request and then evaluating which agent is going to be the best agent to answer it. So if I ask a question about, hey, summarize this document for me or help me understand it, it could go to a business analyst or a reader or an editor agent that can go off and help me kind of analyze something. If I say I want to create an executive briefing, well, maybe there is a pre-configured agent who has all of the templates and the know-how and the background of the organization to do an executive briefing, etc. And so this sequential approach is good for tools, it's good for models, and it's good for agents. And if you're interested, I'd be very happy to take our template 1 that we created yesterday and retrofit it now to be tool-based, so that instead of us searching information, bringing it to the browser, and then allowing the LLM to interpret what's been brought back, which is essentially me or you calling the tool and presenting and handing it the results, we could easily retrofit that and just have an input box and say, ask me anything about projects. And it could go through and it could do its own API call and it could narrow the results. For example, you saw that I was asking questions about the kind of infrastructure projects in a single city. Well, if you wanted a more performant system, you would allow the LLM to put in a structured request and only return results with that specific city that we've asked for, which would make it much faster and it would use a lot less tokens. So if you're interested in that, let me know. I'd be happy to make that as the next demo video. And I hope that this has been helpful for you to understand how to build your own tools and how to understand what is going on behind the scenes when an LLM is interfacing with the various tools you see. So let me know, keep building, and I look forward to hearing about what you make next.